All right, welcome everyone. Today we're going to be talking about PostgreSQL, specifically inside of relational database management systems. We're going to do a quick review of the full stack development process. We'll talk about the history of databases, SQL versus no SQL. We'll then talk about an OP table, which is something more familiar in comparison to what SQL syntax looks like. We'll go into inserting this into a database, and what that's going to look like inside of our Docker file. And then we'll cover something called updating a primary key, which we don't know about yet. So please just keep that in the back of your heads until we're actually going to implement it. All right. At this point, does anyone have any questions over the material that we'll be covering today? Fantastic. It doesn't seem like we have any questions, so let's go ahead and get started. Starting off with our backend development process here. So we've already seen this image a couple of times by now. Oh, the full stack development process. Right. In this image, we talk about the actual browser, or the client, which is what we've been calling it, right? We'll do CLT for client. All right, so CLT for client. The client is actually only seeing our React application, which at this point it's a single page application working with React and Vite, right? Along with all of our routing information, which at this point we're utilizing Axios to make a connection. We're also utilizing Bootstrap for styling, or maybe Tailwind CSS. And even going into something like Cypress for end-to-end testing. All right. All of that is living within our single page application inside of our static files. But this Axios process, what is it that Axios was actually doing for us? Let's talk about that. In regards to the client, whenever Axios was being implemented, it was usually inside of some sort of asynchronous function, meaning that we either had to use the async.then keywords or async and await. But we were typically doing something with Axios. Now, what was that action that we were conducting with Axios? Why was Axios important inside of our front-end development processes?
I was doing the GET request.
Fantastic. It was making requests, right? And by making those requests, what it was asking for was a request for data, right? If we want to take a look at this from a more written perspective, we were having Axios generate a request for data, where that request would go to an API endpoint where we would send something like get. And if we take a look at the Rick and Morty API, I believe it was something along the lines of characters, which was our endpoint. All right, so there's our Axios.get. But we never talked about everything that goes on in the actual backend of this operation. All right. So let's actually take a look at the Rick and Morty API. We come over to all characters. You can see that it's already tabbed out for me. It looks like it's just character. It's not actually pluralized, which bad on them. Proper API convention says they should be pluralized, but that is a-okay. All right. Now, when you go to get all characters, you send this request, and what comes back is a JSON response that looks like this. Let me go ahead and place it inside of a text file. Oh, that didn't work very well. All right, what comes back is a JSON response that looks like this. Now, this JSON response, although it looks nice and neat for us, it doesn't really tell me much about what kind of data it is that I'm working with. I actually don't like the way this looks, so I'm gonna remove it. If we're taking a look at this tab here, where we're seeing this JSON file specifically, what we're seeing here is a representation of an actual database, right? There is a database somewhere that is storing the values that compose a character, where every character, an instance of a character should have name, an instance of a character should have the attribute of status, species, type, right? This is very familiar to something inside of OOP, right? Where when we created a class has attributes that were getting assigned to values through certain getters and setters. Now we know that whenever we're writing application code, data doesn't actually live inside of the client side, nor does it live inside of our server. Our server has one specific duty, which is to format data. That is the point of our server. It's to format data and accept requests, right? Now, there's a little bit more complexity inside of this server, and we'll go into that step by step later on. But what I want to make sure everybody understands is that all of our data entries are actually stored within this database. And when I make a request of any form in any of those applications, a server accepts that request, asks the database for information. The database returns that data. It gets formatted by the server and then returned to the client in JSON format. All right, we saw that practice happening a couple of times with a few different APIs at this point. All right, particularly in the classroom, we covered the Rick and Morty API, and we also covered the Poke API. And both of these APIs function in the same exact way. There is a server that receives requests, queries the database, and then returns a response showing the database entries in a JSON format. All right. Does anyone have any questions about that? Okay, fantastic. It doesn't seem like we have any questions. Let's go ahead and keep pushing here. So all of my data is going to be stored inside of a database. Right? I understand that from this interaction. But what exactly does a database look like? And how did databases even come about? Right? Well, we talked about the history of web development and the application of it when we went over our full stack class. Right? When it came to the very first web application, what did that look like? Does anyone remember?
Was it just the standard HTML page, I guess, displaying?
Yeah, it was very much just hypertext, right? And there was just links of different hypertext files being linked to one another, and it was the concept of link pages that brought the World Wide Web to come about, right? Now, at the time, all of the updates or anything that needed to happen to an application was being done manually. And at the time, when it was serving that small scale of a purpose, because its original purpose was just for colleges to be able to share information with one another when they were conducting research, it was it worked, right? It wasn't too much of a hassle to go and update a specific file. In any case, a forced organization for them. But as the internet started growing and the need for application data started to grow as well, well, that didn't work anymore, right? We weren't able to just store information inside of web pages. There was also specific information that we didn't want to be accessible to everybody, but we still wanted it to be shared depending on specific on character whoever individual was. So that's where the concept of permission starts coming into play. So what would be the next level from there? Right? If I can't just maintain it on regular HTML, where else could I store data?
On the server.
Nice. There was the server, right? The server could have held data as well. But we as humans, we actually turned into something a little bit less advanced than the server. We actually started turning our attention to something that looked very similar to what we interact with inside of Google Sheets, right? These were called flat files. And we just started storing information inside of these flat files where everything was divided into columns and rows. Every time there was a new entry, we would insert data into a new row. All right. From there, we attempted to mimic that information on the server, which started costing a lot of money because now the server wasn't just formatting data and serving its one purpose of formatting data, but it was also storing data. Now, I'm running a server, all right? Let's think about our React application, and we're thinking about the use state function. In this case, we're saving all of our data inside of this on this application. What happens when the application crashes? Where does all that data go?
It disappears.
Nice, it disappears, right? There was a way to conduct really costly backups to try to store information. But essentially, the concept where if our server crashed, there is a good possibility that we may lose some data or have some sort of database management that we need to account for whenever we try to reboot our server as well. All right, so that didn't work either, right? We couldn't store it inside of the server because it was insane to try to mount a server and also maintain the database at the same time. So instead, what happened is we came up with a concept, kind of like the single responsibility principle, where everything was isolated. All right, our static application was being served in one location. Our server, which is meant for formatting data, is stored in a separate location. And then finally, all of the data lives inside of a database. And that's how we came about the concept of databases, right? There was always a need of structured data, and I'm sure all of us have encountered something that required structured data. When I was in the military, I specifically remember keeping Excel sheets for gun crew exams. Anytime we went to the firing range and keeping points of all the Marines as they were doing their assessments. So the need for structured data has always been there. It's just how we store data has evolved. Now, if we take a look at a practical Excel sheet, right? If we go and we just look up Excel sheet image, right? An Excel sheet looks something like this. All right. This is turning a lot more complicated than it needs to be. Boom. Where it's represented by headers, right? That's what we're seeing up above. These are all headers. Typically, we title them. So if we're talking about something like a Rick and Morty application, we would have somewhere along the lines of first name, maybe there's a last name, right? We would talk about, hey, what episodes are they on, which would show up here. And this row, as there's data being written, as there's a new entry being created into our database, notice that they are corresponding to a unique identifier, which we usually reference to as an ID. All right. Well, all of this essentially turns into SQL. And this is how SQL actually displays data and manages data. All right. Now, SQL. What is the point of SQL? If you're telling me that it's just a direct representation of an Excel sheet, what purpose does it really give me, right? Well, SQL brings in the process of relational database management systems. If we are talking about a character here specifically, and let me actually grab my other pencil here. If what we are talking about is a character, well, permanent data that belongs to one specific character would stay inside of this one table. All right, this one table is a representation of my character. Well, let's take a look at that database or that API documentation. This one character was able to hold an ID, which we just discussed. Oh, let me bring that over. Was our unique identifier. We have name, status, species, type, gender, but now we have this thing named origin. And notice how it has a nested object there. Well, this is because I know this because I'm familiar with the way backend development works, but this is actually an indication that this is a relationship that's being managed through SQL, right? Where origins is being held as its own table, and origins has its own entries. Now, when it gets to the portion where we actually have to describe, hey, this character on the identifier of 1 comes from the origin of 2. Well, what this specific line of code here is doing, or excuse me, what this example that we're looking at is doing, is it's actually touching or connecting that one character to the origin of 2. Well, how is that powerful? Let's say multiple characters are coming from the same exact origin. Rather than having to update the data of that origin for every single character that comes from there, it only has to be managed and updated one time. All right. If the name of the origin changes from Earth to Pluto, this conversion only has to happen one time, and it would be reflected on all 3 of these separate characters. Right, this is a many-to-one connection. We'll talk about relationships later on, but this is essentially the power that comes from relational database management systems. Right, they allow us to make these connections from one table to another without having to rely on heavy coding because the system is already built, strictly built to be able to handle these type of relationships. And it's the concept again of the single responsibility principle, right? Anything that belongs to a character should be updated within that one character. But origins may have multiple attributes inside of it, and information that's pertaining to that one specific origin should only live inside of the origins table, especially if it's being shared, right? This allows us to not repeat ourselves. So those two concepts pretty much have stuck with the programming from the very start of the cohort all the way up to here, right? Single responsibility principle and don't repeat yourselves. All right. Does anyone have any questions about what SQL brings to the table? All right. Doesn't seem like we have any questions about what SQL brings to the table. There is the conversation of NoSQL. NoSQL stands for there's no reinforced relationship management. The easiest way to compare a SQL database against a NoSQL database is think about a SQL database as, hey, this has to be in this specific way. All relationships have to be in these three separate orders, and I am not accepting anything outside of those parameters. Where a NoSQL database is my focus is to be able to retain data. How you want me to retain that data, how you want me to create relationships, how you want me to manage getters and setters, all of that, that's your problem. But I'm just going to focus on retaining data, and that's it. Right? So that's the concept of SQL versus NoSQL. Now, that may raise the question, well, why are we learning SQL instead of NoSQL? SQL is pretty much the industry standard when it comes to being able to hold the data, especially higher architecture, um, with higher architecture applications that you may see in business logic. There's usually a mixture between SQL databases and NoSQL databases that are being applied. When applications are running, they usually have multiple servers. They also have multiple databases for different functions. For example, this Zoom meeting that is happening right now. This server is actively sharing or live stream in our videos from one to another. And there is likely a separate server or at least a separate endpoint that is managing our chat, allowing us to actually send our chat to one another. And it's being stored inside of a NoSQL database. Now, why would it be a NoSQL database if it's managing something like a chat? Typically, for something like chats or live streaming, you want something that's not too restrictive, right? Just to allow for any sort of crazy input that may come from the user. So things like that are usually driven by NoSQL databases. All right, I see a hand up. Go ahead, Alex.
Um, I've learned a little bit of SQL through college, but that's about as far as it goes. I know with NoSQL, you have like I've used Firebase a lot, so I know Firebase has like real-time snapshots. Does SQL offer like kind of the same thing?
It does. Are you talking about more for database backing and backlogs?
More for like because I know you query the endpoints to get your data, but they also have like the like real time like snapshot where you only pay for read and writes one time and then to update it as well to kind of keep it more synced for like chats and like text messages and things like that.
Interesting. I think what you're referencing to is the concept of caching. Um, Caching is being offered at the server level, but it's not going to be offered at the database level.
Yeah, it's similar to that. It's like so if you're using a NoSQL database and then you have to pull information, then you have to query it like, hey, we want this collection, and then you get charged for the reads, and then again for the writes. But if you do their like Firebases or I know different like cloud providers have the same thing, but it's like real-time snapshot. So you pay for like the whole collection, and you only get charged for the reads once, and then you can continuously read through it, and then you get charged for the updates as well. But it's like more economic if you're doing like user chats and stuff like that. So I was just wondering if like SQL kind of had the same thing. If that
Yeah,
makes
that's
sense.
that's a good question. I'll have to look into it and get back to you. Because I really don't know off the top of my head. So I'll have to look into it. All right. Any other questions? Okay, perfect. In that case, let's start actually comparing these two to one another, right? What is the point of writing a SQL? And what have we written so far that can look very similar to a SQL script? Well, we're going to go back to our dog example, and where we define a dog. Our dog has certain attributes, and those attributes can actually be demonstrated inside of Python. All right. Go ahead and open this up. I'm going to go ahead and create a file of main.py. And in this main.py file is where I'm going to write my table. All right. I can make my class of dog, write my init method. This should all look pretty familiar to us. And if it doesn't, please let me know. And then here is where we would have our attributes, right? Now, what would be some attributes that could be described about a dog?
Name, breed, color, and age.
Nice. So we could go name, breed, color, and age, right? And we know that we have to utilize the self keyword to be able to do this. All right. Now, every single one of these attributes, they're not created yet because they have to utilize the assignment process, right? So let's go ahead and add that in there. Let's do name, breed, color, and age. Make it equal to name, equal to color, breed, color, and age. Now let's take this a step further, right? Because this is very, I guess, basic Python, right? What type of data structure would I actually be wanting to hold within name? What are we looking at here? All right, I'll go ahead and pass them on then. Jake, what type of data type or what data type could represent our name?
I would assume like a collection of letters. So no numbers, just letters.
Okay, and what is that called in Python?
Um, just like a text. I'm blanking.
All right, yeah, very close, right? We're talking about a string here.
Okay.
Awesome. So now we want a string there. We could even state, hey, we actually also want to define our breed as a string. We would like to define our color as a string. And what about our age? What would define our age? And let me go ahead and pass this one on to Erica.
Integer.
Perfect. All right, we would have an integer there. Now we could extend this something where we could even, hey, keep track of date of birth, and something like date of birth would look like this. So date of birth, which is a type of date, is going to utilize date of birth. Right? And I believe we have to time zone import. Oh man, I'm gonna make it weird. All right, we'll just leave it like that, right? Where we had our time of date to be able to be demonstrated. All right. So there's a little bit of syntax as to how we can actually demonstrate the dog class. Let's go into the process of turning this very familiar OOP that we've seen before, and let's implement it to actually describe it into something like a SQL table, right? Now, a really useful tool for being able to write all of your databases is going to be this draw SQL. I went ahead and shared a link to draw SQL. It's inside of the Corsair channel. All of you should be able to click on that link and it should open up this file for you guys. That way you can watch me in real time. All right, now in here, I'm going to actually write some tables. The one table that I want to write is going to be my dog table. In this table, you can notice that they're already giving me an ID. And there's this button that they're also allowing me to see. You can click that and notice how it's giving you something called an index type. We'll go into that later on. It also gives you some other unique identifiers that it should be unique or it should be indexed. This N stands for, hey, can we accept nullable values? Right? For something like an ID, we wouldn't want nullable values. And let me zoom in one more time. There you go. Yeah, for something like an ID, we wouldn't want nullable values. All right, well, now we can start talking about name. All right, well, our name would be a string. In SQL, strings are represented by a varchar. Now, there is a char that you can utilize, but a char is different from varchar as far as the memory location or the memory space that it utilizes. When you specify the char field, you have to describe how many spaces should be accounted for within the character field. When you specify this, you're essentially, every single time somebody creates this entry, there will always be 50 characters that are utilized in memory space, regardless of what kind of input I'm placing in here. Even if I'm doing just one letter, there's still 49 blank spaces that are being accounted for inside of this char. Now, if I utilize something like varchar and I pass in 50, this works differently in accordance to memory. Now, if I only pass in one letter rather than 50, it would only occupy the memory space necessary for that one piece of content. All right, so it would only occupy one letter worth of memory space rather than having one letter and then 49 blank spaces. All right. By default, when working inside of Django, so this is kind of giving us all a heads up for future lectures, all of our char fields will be written in varchar. All right, we can go ahead and continue describing this. We have our self.color, or in this case, a color, which would also be varchar. And in this case, I don't think we need anything other than 20. And then finally, we can add our age, which there's big integer, there's small integer, and then there's integer. We also get the float field that is available to us. We'll talk about this field later on once we're working inside of Django, but know that we can work with decimal points. All right. In this case, we're just going to go with the integer field. We really don't need either the big or small. Integer field will be good enough. There is a specific division on what kind of numbers they can hold. Integer field will give you a very general coverage for anything human-like. If you're trying to cover something where the numbers are starting to get a little bit ridiculous, like we're talking about going into thousands, then start thinking about moving from integer to big integer field. All right, but here is our dog class represented in SQL. Now, the really cool thing about this website is that after you create it, they do give you a way to actually export your entire file in SQL. You can come over to File, click on Export, and you can see that it can give it to you inside of a Postgres SQL schema. Now, because we are here and we are working within each other, or we're just working inside of a bootcamp, we're not going to actually utilize that feature. Instead, we ourselves are going to create this dog now in SQL. All right, I'm going to bring out this practice SQL, and here I'm going to write my SQL table. Now, this is a brand new language that none of you should be familiar with. But luckily for us, it's actually very straightforward as far as in it utilizes action Um, and it doesn't hold strict syntax with the exception of parentheses, semicolons, and commas. So here's what I mean by that. When we write a table, it is written as create table, the name of the table, which is dogs, followed by all of its attributes. Now, this create table, you can see that it's written in the color of blue. That's happening automatically. You could actually write those keywords with just lowercase letters as well. Both of these would work. Not a good idea. Don't recommend it. It's the standard that keywords are to be written in capital letters. This is to ensure that people can actually understand or identify keywords easily. Whenever you are done writing a query, you should end your query with a semicolon. Right? If my query was only one line, it would look as such. But because my query occupies multiple lines, it looks like this. All right, does anyone have any questions about SQL up to this point? Perfect. If no one has any questions, it's going to actually translating what we're seeing here on our right-hand side over to the SQL table. Starting off with the ID. Well, the ID, we can see that it's an integer, but it holds this primary key index value in there. Well, what we can do here is we can describe that this is a primary key. And by default, this will get set as an integer value. Now, we separate all of our attributes by putting in a comma. I can specify my name, which, as we discussed, is a varchar. I can specify another name, or excuse me, a breed of varchar. I can specify a color of varchar. And then finally, an age of integer. Notice I have a comma for every single one of these entries, with the exception of integer. That is because it is the last argument in my table. All right, awesome. At this point, does anyone have any questions regarding SQL?
Is there a reason that the name is blue instead of white like the other key values?
Yeah, that's a great question. And Erica is referencing to line 3. We can see all of these key words are actually highlighted in blue. This name is a reserved keyword inside of PostgreSQL. Once it's being executed, because of the syntax that we are writing, it's going to identify this not as the keyword, but as a variable. So it's not going to execute the proper behavior. But the reason why name is blue is because it's a reserved word inside of PostgreSQL. Does that answer your question, Erica?
Yes, thank you.
Of course. All right. Any other questions? Perfect. If there aren't any other questions, let's go ahead and start talking about our Docker container for being able to execute PostgreSQL. Oh, we can open up our files. Here's my Docker file. Here we can specify what Postgres engine we want to run. In this case, we'll utilize Postgres 15. I need there to be an app, so I'm going to specify a working directory to my path of app. There's going to be a copy command, and there's going to be a command. All right. Now we are utilizing Postgres, so the last command to be executed will be Postgres. And this will actually mount. The database. Let me go ahead and run Docker PS really quick to make sure Docker is running. I'm glad I did that because my Docker is in fact not running. All right. Now, this is PostgreSQL. It's going to mount the database container. This copy command here, it's actually going to copy all of my project into the directory of app. And now we get into a couple of things that are unique to Postgres. For example, there's a user. There's also a password. And finally, there's a database that we need to store. All right, the database that I want to create will be of Corsair. Notice that I'm utilizing an underscore and not using camel cases. Please avoid capital letters whenever you're trying to name any of your variables inside of Postgres. For the user, I'm just going to use myself, or we could say, hey, student, why not? And let's do the password as student. All right, so this is going to create a database where the user that's going to be interacting with it will be named student, the password is student, and the database is the Corsair database there. All right. Now, when this gets executed, I want this table or this query to actually run inside of my Postgres database. But before we do that, let's go ahead and build or run for Docker. Gonna touch, I'm just gonna call it run sh, give it the proper permissions. All right. Now this run sh is going to Docker build. It's going to build from this current context. So I'm just going to go ahead and say echo building image. I need to make sure that I give it a name. I'm going to call it my Postgres image. Let's go ahead and echo running container. This will take a Docker run. I want to run this. I'm not going to run it on daemon mode just yet, but I am going to give it the --rm flag. I'm going to give it a name of Postgres container. And then I'm going to give it the image. So Postgres image. Let's go ahead and run this. Clear. So there you can see it building the image. Yes, I want it to have permissions. Image is being built. Pulling everything down from Postgres. And then my application or my database gets mounted. Nice, you can see there's a create database query that happened in there. It's giving me the information. And I finally have a query to be able to enter and interact with. Well, how do I interact with this? Let's take a look here. We can try to enter our Docker container. All right, we could run something like docker exec -it, the name of the container, which we named it Postgres container, and then say that we want to enter in bash. If I run ls here, you can see that I will have all of my Docker structure. And I could actually run PSQL and the name of the database that I ran into it. PSQL is a tool that's given to us whenever we download Docker. This container has Docker running, so it should have access to PSQL. Let's just run PSQL-v. Okay, so let's do -v. Looks like it's saying it's ambiguous. This needs to state version. All right, so we can see here that it's giving me, hey, this is a version for PostgreSQL, version 15. Nice. Now we can run PSQL and actually type in the name that we gave the database. Well, the name that we gave the database was Corsair DB. It's going to tell me there's an error. Okay, there's the world root does not exist. Okay, that's because it's looking for me to match the user. So it gets a little bit more specific, right? So I'm going to use PSQL, Corsair DB. I want to specify this is the database. But then I also want to specify the user, where the user is the student. This -d command stands for database, and the -u command stands for user. And you can see that when I execute this, it loads me straight into Corsair DB. Now, how do I know I'm inside of PostgreSQL? Before, I was a root inside of my app, and I was able to write regular bash. Notice how now this occupies the name of the database that I gave. And there's this pound sign. And that demonstrates that I'm actually inside of PostgreSQL. All right. Does anyone have any questions regarding the Docker container, running it, and then entering PostgreSQL? Well, perfect. If there aren't any questions, the next step is actually loading this practice SQL, right? How do I actually insert it? Well, we can insert this data by utilizing a command for insertion. Now that command is \i, and then the name to the CSV path. All right, so we do this as such. We run \i, the name to the path. I am within app. So in app, there is nothing other than just practice.sql. Okay, and you can see that it was able to identify a syntax error near primary. All right, so there we have our create table of dogs that takes in dogs. I see. So the issue is coming from the way we are inputting all of this. So let me go ahead and crash. You could even take a look at the server to see the issue. So, hey, I tried to run this create table of dogs and said, hey, there's something wrong here, right? This isn't the right syntax for being able to run this information. Okay, so I need to get out. I get out of PostgreSQL with the command of \q. That's for quitting. I can then exit, and I could rebuild my image. So first I'm going to run docker stop Postgres contain. That stops Postgres. And I could add serial primary key. And let me make sure all of that is correct. We have create table of dogs, ID name, all of our varchars, everything's separated. I believe this should do the trick. So let's go ahead and get this up and running again. We build our image, build our database. Okay, we're going to enter our Docker container. Then run psql -d. In this case, we named it, I believe it was Corsair DB. Is that right? Yes, it is. Where the user is of student. Then we run \i for practice.sql. And now we can see that a table has been created. I'll send out a list here shortly, just so that everybody's tracking all those commands. All right. Now a table has been created. But how do I view said table? There's a couple of PSQL commands only that we should learn. So far, we've covered two of them. There's the \i, which stands for insertion. There's \q, which stands for exiting. \c will connect us to a different database or different data table. In this case, \d is what we're looking for. \d will actually give us the sequence or the table that we're working with. In this sequence, you can see that we have a schema, a name, type, and owner. The schema is public. The name of the schema is dogs, and then there's table. Well, we can take this \d command for describe a step further. I don't want to just describe the current database that I'm in. I want to describe the data table, where the database is Corsair database, and the table is of dogs. We do this by running \d dogs. And now we should get a clean representation of the dog table inside of PostgreSQL. You can see we have an ID, which is going to be represented by an integer. It has a function for assigning ID classes. There's a name that is a character varying between 0 and 20 characters. Breed varying between 0 and 20 characters. Color varying between 0 and 20 characters. And then finally, age, which is interpreted as an integer. Right, so we took our original OOP file of the class of dog. We then diagrammed it so we could see it as a table. Which I have lost, but it's here. And then we turned it into actual SQL utilizing our SQL file. All right, does anyone have any questions over how we created the dogs table inside of PostgreSQL? Perfect. If no one has any questions, let's go ahead and break this down. This next val function, where is it coming from? Well, we can see that it's coming from this dog's ID sequence. Well, dog's ID sequence is nowhere to be seen here. So how can I find it? Well, here, if I run \d, I get this dog's ID sequence that shows up. And same thing, if I run \d, dogs ID sequence, and I take a look at it, it tells me, hey, this is how this function works. This function holds a type of integer. It has a start and minimum value. It defines what the maximum value, so maximum amount of entries that can be placed. How it's meant to increment, if it cycles, and when it's cached. Right, so it gives you the information on how this data is being stored. All right. Additionally, we could even run a select query, which is the equivalent of saying get. I can run select all from my dog's ID sequence. When I ran this, notice that it gives me the last value that we're counting on is of 1. Currently, the log count is of 0 because I have no entries into this data table yet. And then I have an is called where it's false, right? This has yet to be called. Well, let's put it to the test. We're going to actually write SQL here inside of this terminal. All right. We're going to create a dog. I'll say insert into dogs. I want to insert name, breed, color, and age. The values of Max, German Shepherd, why not? Black, and 4. And then I'm going to run that insert query. And it knows it's actually being executed because of the semicolon at the very end. And I get there, hey, there's been an insertion of 1. Go ahead, Jake.
To insert multiple values, would you just have like a set of values in parentheses? So you would just do like parentheses max, but then in the next parentheses have like Riley or something like that?
That's correct. Yes,
Okay.
you can have multiple parentheses wrapped up. All right. So there's my insertion. Now let's go ahead and take a look at the select query. If I run select all from dogs ID sequence, we can see, hey, there's a last value that was used. It's still 1. There is something inside a log count. And now it's true. Nice. Let's go ahead and select all from dogs. And there you can see in our table, we have Max at the ID of 1 that has been inserted. All right, now this doesn't really resemble what an actual workflow would look like if I was working in SQL and picking up a project, All right. I'm not going to go through the process of manually inputting every single database or every single entry in the database. Let's say they give me an Excel sheet. It'll be observed for me to go through an entire Excel sheet and make all of these connections. So instead, what we do with SQL files is we make them reusable. We make this reusable by saying drop table if exists dogs. This is essentially saying delete dogs if it already exists. We then create dogs. And then finally, we're going to pass in the copy command, where we're going to copy content from the CSV file. All right, so here's our dog data CSV file that holds all of the dogs we want to place inside of our database. We're not going to do each one of them one by one. Instead, we'll just grab the CSV file and copy it all into my database, into my data table. I apologize, I got to close some files just to do some file management here. All right. Well, let's go to this copy command. What this copy command is going to do is it's going to copy into dogs ID, name, breed, color, and age. I'm going to copy from, and I need to specify from where it is that I'm going to copy. Within this location, dog data.csv with a delimiter. And very important, note that this all has to stay in the same line. It's just one of those SQL gotchas where the copy command has to all remain inside of the same line, where there is a CSV header. And let me write this as such. All right, so this is going to copy into dogs the value of ID, name, breed, color, age, which is all happening here, from dogdata.csv, where the delimiter, the value that separates each one of them, is a comma, right? It's not a space. Our delimiter is a comma. And know that there are CSV headers that are included. And if I take a look at the top, there are definitely CSV headers that are included. All right, let's go through the process of getting our Docker mounted one more time. But I'm actually going to update my run command here. So it's a little bit more dynamic because as of right now, I'm having to recreate everything over and over again. I have to take down my container, I have to remount it. Instead, I'm just going to create a volume to be able to track in memory space any changes that happen to my Docker file. I'm going to do this as such. I'm going to add the -v for volume, where here I'll pass in the environment variable of my working directory to practice.sql, and I want it to match my app directory at practice.sql. I'll also create, and actually that's all I need. I'm not going to be interacting with the data. All right. So this way, once I remount it, any changes that happen to this file will always remount as well with it. So finally, we quit, we exit, we stop our container. I'm going to go ahead and restart my container again with run sh. That restarts my container. Let me make sure there weren't any sort of errors. All right. I can go ahead and enter said container with exec. Here I'm going to run PSQL, where the database is Corsair DB. and the user is student. And I'm going to run the insertion for practice.sql. All right, and it looks like we're having a little bit of an issue here. It's telling me, hey, there's an error near delimiter. I likely spelled delimiter wrong, which I wouldn't be surprised if that's the case. Um, Dog's ID color.
Yeah, it's delimiter.
I see. So it's delimiter. Okay,
Oh, with a DELI and then MITER.
DELIMITL. Thank you
Yep.
so much. Nice. All right, I've updated it. I'll make sure to save it. Let me try to run that insertion query. Now it dropped the table because the table already existed, and then recreated the table, and it copied all 30 entries of my CSV file. Now, if I run my select query, like I did before, of select all from dogs, you can see all 30 entries of those dogs from my CSV file into my database. All right, this is where we're going to stop at part one. Part two will go into constraints and queries. We are covering a pretty substantial amount of information. I am tracking on that fact, and there is a reason for it. We'll be diving in deeper into each one of these concepts as we start talking about it in Django. All right. At this point, does anyone have any questions over any of the information that I've covered? Perfect. If there aren't any questions, I'm going to go ahead and stop the recording here.